Good afternoon. My name is Don Drake. I'm a Senior Analytics Specialist Solutions Architect at AWS, and Discover Financial is one of the customers that I'm dedicated to for assistance in their analytical workloads in AWS. Today, we will hear about the journey Discover Financial took to take mainframe-based payment applications and get them running in AWS using modern technologies. This migration was no simple lift and shift. As you will see, it took both changes to technology stacks as well as to their culture, all while ensuring the modern applications run securely and reliably in AWS. By working to migrate its card settlement environment to AWS, Discover maintained security and enhanced the developer experience while increasing processing speed, all while reducing the time to adopt pricing changes. This mainframe migration will ensure Discover will continue to be a global financial leader. Today, I have the honor of introducing our speaker, Ewan McPherson. Ewan is the Director of Payment Services at Discover Financial Services, and today will tell us all about the journey he and his team took to migrate mainframe applications to modern applications running on AWS. Ewan, take it away.
Hey everyone, thanks for joining and thanks Don for that introduction. Yeah, my name's Ewan McPherson. I'm a director at Discover Financial Services, and I'm here to talk to you a little bit about what it takes to move a mainframe application to the cloud, or to be more accurate, how to partially move a mainframe application to the cloud, or as I like to say, how to strangle a mainframe. And for the short answer for anyone who wants to get out of here in less than 1 minute is, of course, very carefully. And for those of you who are only here for that punchline, thanks for coming. Thanks for your time and have a great rest of your day. For the rest of you, this is how the rest of this story is going to pan out over the next 40 or 50 minutes or so. So we all know that movies are narrated out of over 4 acts. For this story, you're going to get a bonus act, which is we're going to do it over 5. We're going to kick off in classic movie style with the setup, where I'm going to give you a bit of context and background into the whole story. Then we're going to move quickly into the explanation of the strangler pattern itself, and then I'm going to give you some more gory details on the solution before we finish up with the big reveal, or as I like to call it, the what we learned bit. And then, because this is a bonus cut director's version, you're going to get that extra bit at the end where I'm going to tell you how we achieved all of this through the power of transformation. But before all that, I'm going to give you a little bit more about who, what, and where I am. As Don said, I'm from Discover Financial Services. I'm actually an application development director there in the Payment Services Department of Discover, and I'll explain a little bit about payment services in a minute. Discover, as I'm sure all of you know, is a very large and very reputable financial institution. I'm sure there are many of you who've actually got Discover cards in your wallet right now, virtual or otherwise. What some of you might not realize is that Discover is actually one of the leading digital banks in America. We're actually also one of the 3rd largest and fastest growing credit card networks in the world. We're also one of the leading providers of student loans in the US, and we've got a massive portfolio of home and personal loans. All of which is to say, we've got a lot of responsibility to be good financial custodians. And as you might expect, we're quite rightly and very heavily regulated, both here in the US and globally as well. You know, and that is to say that you know, we take security and compliance very, very seriously. It's in our DNA, and I'm sure those of you with Discover cards are very pleased to hear that. So it's one of those things that actually makes this story a little bit more interesting, because when cloud services came along, however many years ago, companies like ours took a very long, hard stare at what all of that would mean in terms of security and audit, PCI, SOX, all those different kind of things. And how we navigated this migration in the shadow of all that regulation is a key part of the story. So for those of you who don't know what payment services is, it's the part of the network of applications and platforms which supports all those credit card transactions, debit card transactions that we all love to do. You know, without sort of application, without that platform, none of that would happen. And for those of you who don't know exactly how payment transactions operate in the flow of the system, I'm going to give you a quick explanation because it's kind of relevant to the overall story. And we got this ABC easy way of trying to remember, which we call the Manic model. And so in the Manic model, we've got the merchant here on the left-hand side on the slide. And the merchant is the shop or the ATM or the online service that takes your card details. They send it to what we call an acquirer, which is the financial institution that owns that relationship with the merchant. The acquirer then sends it up to the network, in this case, Discover. And then Discover, we look at the transaction, we figure out which bank issued that card, and we send it off to them for authorization. So hopefully they say yes, we send that information back, and with any luck, you walk away with your goods. So at the end of the day, the merchant then bundles up the transactions and does something which we call settlement, which is, again, relevant to this story. So they take a bundle of transactions, they send them all the way up the chain again until eventually, hopefully, they land on your statement. And at that point, the network is responsible for making sure everyone gets paid. So we figure out, we price the transaction, we figure out how much everyone needs to get because there's a cost of doing business in this flow. And then we instruct everyone to move the money. So that's it really, pretty simple. Hopefully you're with me so far. So why am I telling you all this stuff? Fair question, partly because we're still in the setup part of the story. And mainly though, because this ecosystem of network applications and platforms that support this Manic world that we support is a highly critical link in the chain of events that makes the payment services world go round. And making changes to that ecosystem should never be taken lightly. So, you and me, we like to buy stuff, and we really don't like anything getting in the way of that. Merchants, banks, they like to get paid, which is, fair enough. So again, no disruption is the name of the game. And it's partly why the payment services world has, for the longest time, been a very conservative, very stable, unchanging kind of world. And it's kind of why companies like Discover and others in the payments world have supported their applications for decades, sometimes on mainframe applications, often using languages that pretty much all of you in this audience are too young to remember, I'm guessing. However, so like plenty of other industries, the payment services world has undergone an unprecedented amount of disruption over the last 5 or 10 years. So, whether that's from fintech organizations or even big tech organizations, mentioning no names, all of whom trying to get into the payments business. Whether that is to move us away from physical cards onto, paying for things with your phone or your watch or your shoes or whatever. Basically, the world's become obsessed with paying for things in, new and crazy ways, which, I think is fun and exciting, I suppose. I mean, who doesn't want to talk to their fridge and ask it to pay for its own milk? But, enabling this fun and exciting fridge behavior is kind of challenging using technology that was designed and intended for operating in a much more relaxed era. It'd be a kind of like trying to get a pigeon to deliver your tweets. It's kind of doable, but you may miss that moment. So, in lots of ways, I would say, the days when you used to pay for something on your credit card and it didn't used to land on your statement for another 6 weeks, I kind of missed that, actually. It was kind of fun. You could kind of spend, and then you could just pretend that nothing had happened for 6 weeks. These days, if I don't get a notification for something I did 5 seconds ago, I get kind of twitchy and phone the fraud squad. So it's kind of interesting times we've kind of developed for ourselves. And that's a kind of long-winded way of saying that in the payments world, although we've had lots of great legacy applications that have served our business for many years really, really well, some of it may not be best suited to support us in this newer, faster world that we live in. And I say some of it because, you shouldn't just assume that you should scorch the earth, just to kind of make this new and fun, exciting alternative universe happen. It's the same way you wouldn't demolish your house just every time you wanted to modernize your kitchen. Well, I wouldn't anyway. So in the case of Discover, we're really lucky to have a forward-thinking leadership team who many years ago decided that perhaps we need a platform transformation. And not just to sort of enable us to meet the need for speed in the new market, but actually because we are in the very unique position of having 3 networks, 3 for the price of 1. First off, we got the Discover network, which is domestic credit cards in the US. Secondly, we've got the Pulse network, which is debit cards in the US. And then thirdly, we've got Diners Club International, which supports the need of our global customers. So we kind of got 3 networks broadly doing the same stuff, supported by 3 separate teams. And to be honest, it's not unfair to say that that can cause friction sometimes for our customers. So we've got lots of good reasons to move on. And for the longest time, we've been working on improving that situation, not just to modernize the platform, but to move the business forward. And as part of that, we've been obviously taking a look at our technology choices, like the cloud, and transforming ourselves along the way. So it's been fun times all round. What we've landed on is this crazy looking eye chart here, this new ecosystem. And I'm not going to go into details, there's too much detail here, but essentially what we're looking at here is what you might call a modern classic event-based microservices kind of ecosystem. You've got an event bus in the middle there. You've got a object-based big data operational data store at the bottom. And then surrounding it, you've got all these microservices that are supporting the needs of our customers. Now, obviously, this is the kind of showroom brochure version of our ecosystem. I can't say it's perfect at the moment. It is a work in progress kind of deal, but you know the sort of thing. But we are actually inching ever closer to that platonic ideal. So, I'm sure many of you can identify with that. So in the heart of this ecosystem sits the settlement platform. The settlement function, for those of you paying attention earlier, is the bit where everyone gets paid. You could say it's a very important part of the system, if not the most important part of a payment system. The clue is actually in the title, payments, if you think about it. Anyway, in the case of Discover, like I said before, this function has been supported for many decades on a set of mainframe applications. Say what you like about mainframes, but they do get stuff done. They may not be the most nimble of dancers, but they stick to the rhythm and they don't miss a beat. If you want to get your numbers crunched, you can't go far wrong. And that's kind of all great and everything, but if you want to start upping the tempo a bit, if you want to start responding to the younger crowd and start playing the latest tunes, if you want to start throwing a few new shapes on the dance floor, as it were, then your mainframe might start looking a little bit clumsy, like it's got 2 left feet or something. And that kind of gets to the question of why. I'm sure there are plenty of organizations out there thinking about migrating away from their monolithic mainframe legacy applications and asking themselves, why bother? It still crunches numbers in super quick time. It's really dependable. But if you are like us in Discover, facing up to the various market threats out there, if you want to move faster, if you want to make more change, then you might want to start looking for alternatives like the cloud. And there's another reason. And I call this one the knowledge gap. It's kind of an interesting one. I'm not particularly picking on mainframes, especially here. It could really apply to anything that's built over time. I guess, but the older the system, the bigger the potential problem, I guess, is what I'm saying. Because, we all know the situation. Those damn documents, those damn design documents, they've got a habit of getting out of date, right? And that's if you can even find them. I mean, more likely they were printed out on a daisy wheel printer in 1982 and the ink has long since faded. Actually, even more likely they've been lost behind the radiator somewhere. But don't worry, because the team that designed the system, that built the system and wrote that document is still around. And they got everything they need stored right up here. But oh dear, that same team is getting to that point in their career where that Florida retirement home is looking kind of nice. And weirdly, getting those go-getting kids coming out of college to learn COBOL, Fortran, assembler, whatever, is a bit of a tough gig. Actually, a weird aside on all of those things is that those languages are actually getting premium rates on the contractor market these days, and that's been like that for a while. So it's kind of interesting, really. So here's what you're left with. You either risk losing all that hard-earned knowledge of your team as they naturally disperse back to Florida, or you risk migrating your mainframe to the cloud. And so in the case of Discover, we've been taking the plunge, and we've been busy mining the great brains of our legacy teams for all it's worth as we slowly shift that mainframe to the cloud. And the question is how to do that. So we've chosen this strangler pattern, right? So the strangler pattern, it's a kind of interesting name for a design pattern, I always think. It's kind of brutal. When you think about it, the image it conjures up of slowly squeezing the life out of something seems pretty harsh to me. The actual truth about the strangler pattern is it was derived from the growth behavior of the strangler fig tree, which seeds itself on a host tree and slowly grows around it, killing the host as it goes. Which, is still pretty brutal, I guess. That term was actually coined by Mr. Agile himself, Martin Fowler, to describe the business of incrementally migrating an application away from a legacy system and building all the functions around it. So I suppose the fig tree analogy is a little bit less brutal, but it's still pretty harsh, if you ask me, on the poor old mainframe that's been running our business all these years. The odd thing about the strangler pattern is that the opposite of a strangler pattern, if you think about it, is a big bang, which is hardly less violent. In fact, it's kind of scary. And maybe that's the point about this language, because migrating away from these old systems is inherently very risky. And to give you an idea of how we've managed ours, I'm going to run through some slides here that give you an idea of the scale that we're looking at. So here we've got a view of the classic settlement system. And I'm going to start calling it classic because I've started to realize that legacy sounds a little bit disrespectful, like old and redundant. So really, this is the classic settlement system. It's a bit like a classic car, really. It still motors along. It still gets you where you need to be. It just needs a little bit more care and attention to keep it on the road. So anyway, technically speaking, we've got the classic settlement system, which is pretty capable still of crunching numbers. That's what it does. So it's capable of processing, at the moment at least, more than 300 files a day, up to 16 million transactions an hour if you want it to, day in, day out, year on year. So it's really no slouch. And technically speaking, what we've got here is actually called a modular monolith, because there are 2 or 3 different sections that exist within the mainframe that can be deployed independently. But within each of them is a monolith. And that's because all of the functionality, vast amounts of it, all very tightly coupled as a single unit. So it's all or nothing when it comes to change. And you can imagine, if we were to attempt to change all of this in a big bang, with that violent terminology, can you imagine the potential disaster you might have on your hands with that? I mean, thousands and thousands of lines of code, all being deployed in a single hit. Kind of scary, not something I would really want to sign up for. So the idea here is to identify modules, or preferably pieces within modules, that you can reasonably recreate elsewhere so that they act in production in concert with the mainframe until you slowly switch off that function in the mainframe. And that's kind of what we've been doing. In our case, we chose the pricing function as our first component to migrate away from the classic settlement system. So pricing is essentially the calculation engine at the heart of any payment system. It's lots of rules, it's lots of variables, lots of ways of cutting it, and depending on the nature of the transaction, you price it in lots of different ways. So the good thing about the pricing function is it can be sliced and diced in lots of different ways. And there's a huge strategic value for this from our business. We remove it from the monolith in favor of a more granular configuration engine in the cloud, and we actually open up the possibility of greater flexibility, a lot more consistency, and definitely a lot more speed to market than we used to be able to do with the mainframe. Because in the mainframe days, a typical pricing cycle where we would deliver new changes to the network would probably take 6 months. So, end to end with the cloud version of the pricing engine, we can make those changes whenever the business needs. And it's possible for us to get them from requirements to production in less than a sprint, if needs be. On top of that, moving the data that drives those pricing calculations to the cloud opens up the possibility of providing dashboards and analytics to our business partners so that they can observe that data in ways they've never seen before. And that could in turn reveal new and sophisticated ways to price the data. So lots of simple but obvious goodness for everyone, really. So getting that to that point was obviously our goal. Getting the mechanics of that migration to act in a seamless way was really the challenge. So de-risking this kind of migration, that's critical. So this is a day-to-day operational system that we're talking about here. That can't be paused when you're flipping from the old to the new. And once we were confident of that, you can switch it over. But first of all, the key to it was to make sure we compared the data. So we ran the new version of that pricing engine side by side with the mainframe, day to day, running every single bit of data so that when we were confident, we could just switch off the mainframe and switch that piece of functionality on in the cloud. Sounds simple, right? And that's exactly what we've managed to do. And in completing this strangulation phase of the mainframe, we actually managed to do that with 0 incidents in production, which is great. And we did it completely seamlessly. And in so doing, we have also reduced the execution time of the pricing function in the settlement process by more than 50%, which is pretty significant, really. Pretty happy conclusion for everyone. So one interesting side effect of this approach is running the data side by side, comparing and all of that. We actually uncovered issues in the old system that the business didn't even know were there. So, you should not assume that the old system is always correct. It's a bit like, when you have a spring clean and what you find behind the sofa, you really don't know. So, take it all with a pinch of salt is what I would say. And the question I know most of you are interested in is, how do we solve this solution? And I'm going to get onto that in a second, but just quickly going to run through here the different phases that we're kind of planning for the next set of strangulation. So we're going to slowly move that functionality on the right here on the screen over to the left in the cloud. File validations, in this case, then fees. We've got a whole other set of iterations that are planned, but more than this. But this will ultimately be the final version, all of it in the cloud. So. Okay, so onto the solution. So I'm pretty confident that it's no spoiler to announce that we achieved all of this through the wonderful world of cloud technology. Thank you to our gracious host, AWS. But the miracle of this cloud solution didn't come out of thin air. Obviously, it's often the case in my experience of listening to these "Isn't my cloud solution great?" stories that people give the impression they kind of think of this stuff in the mornings just after breakfast. They have a quick break for lunch and a couple of pizzas, and then boom, it's all done at a flick of a switch, and everyone's home in time for Netflix. But of course, that's not the case. Certainly not the case for us. We had several goes at this, and in part. That was because of where we were in Discover's cloud journey, which is to say we were at ground zero, pretty much non-existent. So I'm going to get on to that 3-step phase of our solution in a second, but first, a quick intermission. So, right, Discover's cloud journey is what I want to talk about now. So when we started thinking about our settlement migration, we really didn't have any access to external cloud, as I mentioned. We were pretty mature, I would say, in the internal cloud. So stage 1 was really about internal cloud. And I think that was a concept that was quite appealing to a lot of companies like us at the time for various reasons. First of all, the technology was great. Second of all, it was hosted on our data centers. So, familiar territory and all of that. Actually, it was really great for getting us to migrate away from those heavyweight application servers I'm sure we all love and remember. And it also got us into the habit of writing cloud-ready 12-factor apps. So, overall, very appealing for what were historically cautious companies like Discover, where not taking risks with our customers' data is kind of paramount, because at the time, the actual cloud seemed like it was fraught with risk. So, the obvious place to be, really. Step 2, or stage 2, was what I call the toe dipping phase, where our internal cloud teams made available to us certain aspects of functionality in AWS from our internal cloud. So things like RDS. And actually developers jumped on this because even though they were calling it from the internal cloud, there's a lot of friction still at this stage in standing up new tech on-prem. So that gain, we still had a huge gain to make from calling from the internal cloud. And at that point, they gave us sandboxes. We were kind of playing around a little bit and getting familiar. But nothing seemed to get really real, I would say, until around mid-2017, something like that, where our analytics team decided that managing their big data warehouse needs on-prem in Hadoop at the time just wasn't going to cut it. And they made a big push to move to AWS. So I guess it wasn't uncommon at that time for companies like ours, where there was suddenly a big recognition of the value of big data as a value differentiator was really important for us. And for the rest of us in the organization, it was great because it meant that we were forced as an organization to get over those security fears, those risk fears that we had. And, I guess this is a kind of a common story, like I said, where there is a big business need, things get done in the necessity of virtue and all of that kind of stuff. So we managed to get over our security first culture, I would say, at this point. And then stage 4 is kind of where we are, where our payment services teams, actually early 2019, something like that, were given the opportunity to kind of start migrating. And at this point, where we're moving what we call key core applications like settlement to the cloud, there are extra layers to consider. So these are operational day-to-day systems, not analytics, which runs in the background, as it were. So extra gates, extra security, extra compliance, all of those things had to be worked out and figured out. And that's kind of where we are now. So with all that context, I am going to move into a brief run through of how we arrived at our solution. So as I mentioned, it was done in 3 stages. So take 1 was, as I mentioned, with our internal cloud. Using Spring Batch on the front end, we had Hadoop on the back end, and we had Spark in the middle, running all our event aggregations. And at this point, we're still pushing a kind of event streaming, microservices kind of model. The problem was, in the real world, our main customers were still operating a kind of end-of-day batch-based system. So you've got the traffic was actually really, really bursty. So you will get these files, sometimes very large files, arriving randomly that had to be processed in a very small window. And running the idea of running that kind of process on an internal cloud is definitely troublesome. So it's definitely doable. You just need a lot of server power to be available to that internal cloud at all times, just for that kind of small window of activity. So that kind of led us at the point of 2019, like I say, to take 2, when the cloud did suddenly become available to us, and we kind of jumped at it. So take 2 was, like I say, where we moved to the cloud. We still, to be fair, are processing files on-prem at the point of entry, which actually is still the case now. But it is a kind of hybrid. So we've got this microservices event streaming model running in the cloud for what is a kind of batch-based system of our business. So a kind of hybrid, really. We basically took our first design and mapped the components to the equivalent AWS components. So you kind of got Spark, for example, is EMR in AWS, obviously. We started using S3 buckets for our file storage, which is pretty standard. One of the big things for us in the middle of the slide here, we were using Kinesis Streams. So we had to switch to using Kinesis Streams, which was, some great tooling here. And when we compare it to what we had on-prem, which was Kafka, a lot more flexibility. But, there are a lot more ways to connect to Kinesis, a lot more application libraries available. So how to optimize for our use case was definitely the challenge. That said, this design certainly nailed that problem we had with bursty traffic with the internal cloud, because obviously we were able to take advantage of auto-scaling, so that we're only running the compute when we need it. So much more cost-effective from our point of view there. So one thing to mention with this kind of microservices, event streaming kind of model is it can be harder to operate. So when you've got all these events sort of bouncing around the microservices, you have to handle those all of them from an auditing point of view. Whether you need to guarantee delivery, whether you have to replay those events, that can be a significant amount of extra engineering. And to be honest, even though we looked at this model and figured that this is just perfect for us for a real-time processing paradigm that we can see in the future, sometimes you have to take a reality check and acknowledge that maybe this isn't the right thing for right now for your business, which is exactly what we did. But the good news is we wrote this in a way that could be extended and changed when the business needed to. Okay, so that sort of led us to take 3. So once we got over the weeping and wailing and gnashing of teeth at discarding our wonderful event-based microservices model, we got on with the business of trying to optimize this batch-based system in the cloud. And actually, we found it was surprisingly lent itself quite nicely to our kind of traditional business model. And so in this version, we're still taking the data on-prem, like we said. We're moving up to S3, like we were before. But from there, we're throwing it into EMR in a cluster that is much more compressed. And so the EMR at that point is doing all the processing. So we've got validation, we've got enrichment, we've got aggregation and auditing, the whole shebang. And from there, we kind of pump audit the output files back to the ranch for further processing on the mainframe. Because don't forget, this is still only taking a portion of the functionality from the mainframe. This is the pricing strangulation phase we're talking about. So we do those calculations in the cloud, send it back to the mainframe, and it figures out how and who to pay our customers. So in the future iterations, we're developing more pipelines of similar nature that are coming up, like I mentioned, that will ultimately take over all the functionality of the mainframe. We'll take over the file processing, the back-end money movement, the reporting, everything. So as a side note, as you can see on this diagram, we continue to use Kinesis Streams, and we're using this as a mechanism to manage our audit trails, because clearly in a financial transaction system, you cannot lose transactions. So you have to continue to track every single thing in and out of the system, and I'm going to get onto that in a second. But first of all, a little word on security. So the security question, security and audit. In Discover, they're 2 of our favorite words. They are words that can strike fear into the hearts of lesser organizations, but at Discover, we love them. We kind of got the t-shirt and it's in our DNA and all of that kind of stuff. So exactly what does that mean in reality? And how do you make that thought a reality? And the answer is obviously blood, sweat, and tears, but here are a few actual things. Right, in terms of cloud security, I'm definitely not here to give away any of Discover's major secrets, but mainly actually because I'm seriously underqualified to do that. But suffice to say, under the expert guidance of Kyle Sheldon, who's our cybersecurity head, who's actually spoken on this topic in other AWS events, you can find that on YouTube if you're interested. They've really done an amazing job for us in making AWS a kind of safe and secure place to play. So, security teams, they like to talk in terms of, security hygiene, and we are extremely germ-free in that regard. They also like to talk in terms of blast radius, or minimizing the blast radius, which to you and me means reducing our access to the point where it kind of minimizes the possibility of any damage that we might do. So essentially, we're kind of locked down, I guess. And it's true to say, as far as I'm told, that 95% of security issues are really self-inflicted. And that means, you've got all these great AWS services, but maybe you're not configuring them correctly. If you configure them wrong, then bad things may happen. So to avoid these happenings, our cyber team have kind of obviously imposed a bunch of guardrails on us to avoid those engineering teams doing stupid things. But if they do mess up, then we have governance and controls that kind of catch them before they hit prime time. So as you can see, this list here, these are the kind of things that we've got. Direct connect over private links to AWS, so no internet access, that's from our own network. Likewise, private VPC access to S3 buckets, nothing on the public internet at all. So obviously we're using IAM, segregated accounts, that goes without saying. We've got Warden monitoring, which is tooling we've got of our own around configuration management. And then we got short-term credentials for all our secrets management, no long-lived secrets. And then all our security tasks are kind of bolted into our automation pipeline. So lots of goodness there. So on to the next point, which is compliance. So compliance is a big thing for us, obviously, as a financially regulated company. Our biggest audit, I guess you might call it, the thing we really need in order to do business is called PCI, which is Payments Card Industry Compliance. For those of you in the payments industry, you'll already be aware of that. It's very heavily focused on security, all the things I just mentioned. And there are other regulations for other industries, very similarly focused on security. So moving to the cloud definitely represented a challenge for us and our teams. And that's, like, I think the best thing I can say about that is collaboration with your cyber teams and your audit teams is really where this really comes into its own at this point. A big chunk of the stress for us of making sure our data is protected comes from how we handle our accounts and our secrets management, as well as our policies and on archiving and purging, which we have wrapped around S3. Significantly, I would say the tokenization of our critical risk data is a big factor in us gaining compliance. And all of that tokenization is done on-prem. Another big factor for us is how we move our data from on-prem to the cloud. And in our case, like I mentioned earlier, we got direct connect from our own network. We're using VPC, private links to S3 and all of that. So that's kind of key. And there are other measures in the details, but essentially that's it, really. It's really about access to your data, the data at rest, data in transit, and the data itself. All very tightly managed, all very locked down. And as I mentioned, lots of guardrails on top of guardrails, essentially. So, final word on the gory details around audit and so on is our solution for audit and reliability. As I mentioned earlier, when you're handling financial transactions of any sort, it really doesn't go down well if you lose stuff. It's not a good vibe at all. So when you're moving data from on-prem to the cloud, when you're moving it really from any one place to the next, it's always a good idea to add controls and checks and balances, which is, to be fair, I suppose, standard procedure for most of us, right? So the question of how you do that, though, from on-prem to the cloud is really what we're talking about. So moving to a more compressed architecture for us, away from microservices, actually helped us in that regard. So as soon as we're in EMR, we're pretty much in good shape. But even still, we need to keep track of things. And that's where we've continued to make good use of Kinesis Streams to help manage that audit trail process. Essentially, what we do is we tattoo every transaction with trace data that relates to the settlement window that is configured in the system. And that data is persisted to DynamoDB. Then at certain points, we trigger events that tell us that those windows are closed. And at that point, our Windows management service on the top right there kicks in, does all the checks and balances, ins and outs, and all of that kind of stuff. And if we find any issues, we use CloudWatch to raise alerts, send that down to ServiceNow on-prem, and we all get phoned up in the middle of the night, and we're all happy. Or maybe we're not. Okay, so there we have it, actually. We're reaching the end of the show, folks. And as every American Idol contestant will tell you, it's been a journey. So the question is, have we learned anything? Or more to the point, have you? Or have I even learned anything? The good news is that there is no quiz at the end of this talk. And like a good Agatha Christie murder mystery, and like every episode of Columbo ever, because I like to keep my cultural references bang up to date, everyone. There's a bit of a recap here on the things I've been trying to hint at over the last 40 minutes or so. So firstly, on the approach to the strangler pattern. The poor old classic settlement system being strangled to death. The first thing to note is make sure you have a good reason for doing this. Do you understand why you are doing it? Is there a business case, or is it just a technology play? And either way, it has to be justifiable, right? And even if there is a reason, are you sure you need to migrate everything? There may be a strong case for keeping something elsewhere. On the second point, if you're going to strangle slowly. Weirdly, it's kinder in this instance. It's certainly less heart attack inducing. Because, and keeping our DevOps principles in mind, smaller release is obviously the better. The less moving parts, the easier to control, the less impact if things go wrong. But there is a balance, because when you're moving from old to new, inevitably you're going to want to make changes on the old in order for it to work together. So if you have lots and lots of small increments, you're likely to be increasing the complexity on the old. So you really have to balance that out. The third one is kind of obvious. Hopefully, if you can use data to drive your decisions before you switch things off, preferably production data. That's ideal. But also remember that the old isn't always necessarily going to be accurate. It may be something you need to check. So on the technology side, though, the technology front, as I mentioned, we made a few missteps with our solution before we got it right. Not everyone has that luxury, which is kind of unfortunate, because there are a lot of technology choices out there. And we've been fortunate enough to be able to try out our solution and learn from our mistakes. Excuse me. We first of all, interestingly, thought we were going to work with a futuristic microservices design in this case, but it turns out the cost benefit for the business just didn't stack up at this point. So, making it adaptable, though, if you do make changes, so that you can change again and pivot in the future, is really a key thing. So the final point I've got on here about automation is kind of, I wasn't sure if I needed to even put this up there. I don't know if there's even a debate about this anymore, right? It's, whether it's infrastructure, security, testing, deployment, I think the case for automation, as our mate Columbo would definitely have said, is definitely closed. Okay, so that kind of concludes the main part of the story. But a movie's not a movie these days without a bonus director's cut. And since I'm the director in this case, I'm going to give you that extra bit. In this kind of forum, I would say it's kind of easy to think that everything happens at the flick of a switch. The great services that we get from AWS, they all come for free, and people are just running around in slow motion, frolicking around in green fields, and the technology just builds itself, which of course it doesn't. The technology, I would say, without the transformation is like Cagney without Lacey, or if you prefer, it's like Beavis without Butthead, because I like to give you more of those up-to-date cultural references. The point here is, sure, the technology is definitely a big part of it, and AWS does a really great job for us of making it easy. But if you want to succeed beyond season one, you'll also need to look at your people and your process and how you use them. In other words, your culture. So I probably could spend another hour just talking about this section, but I won't. I've had the big reveal. I know you want to get on with your lives, so I'll just cut to the chase here. But my point in this section is to say that in a lot of ways, the tooling is the easy part. But when you're moving from a legacy landscape to, like many of us have been, the old ways of doing things might not cut it anymore. We've all got the Agile t-shirt by now, but what does that really mean? So lots of companies, I know, and we all know, right? They all look at Agile or DevOps as a straight replace for something that's gone before. And it's easy to see it that way. I kind of get that. But there are two big problems with it that I've seen when looking at new ways of doing software. And they're kind of two opposite sides of the same coin, actually. The first is the people responsible for owning the new process often see it as just another, through the lens of their old process. So it's just another set of new steps. It's new rituals, new checkboxes to kind of tick off. And that's the main issue I've seen when people are implementing Agile. So you may have heard the term cargo culting. If you haven't, go ahead, look it up. It's actually kind of interesting, but it's where you mimic an old process by just replicating some rituals, ticking a few boxes, and then, hey presto, boom, you're done, you're Agile. And that's mistake number one, as we all know. As we know that Agile is a set of principles, it's not something to be followed by rote. The clue is in the title, as it were. So the flip side of that problem is when you do get people who get the principle of the thing, they often apply a level of zealotry to the thing that makes it equally restrictive. So the kind of thing, the gospel according to the Agile Manifesto. Thou shalt not use a Gantt chart or whatever. I mean, really, I'm not sure anyone should really care about that stuff. When people look back on the DevOps and Agile wars of the 2000s, I really hope they're not judging them on whether or not they used a Gantt chart or whether they used this tool or that tool or whether they wrote a requirement for a reverse engineering project like ours. Basically, you just have to decide the principles you want to operate under. And if you get a few people that understand it, that's great. But sweating the small stuff, I think we just need to get over ourselves is the point. Okay, so the people versus the technology. Like I said earlier, the tools are the easy part, really. And we should say a hearty big thank you again to AWS for what they've given us there. But people are hard. People don't come with a manual. They don't come with a user guide. So as it says here, we're in the era of software and the developers kind of rule that world. So kind of what makes them tick is the question. What makes them happy? Especially in these difficult times when everyone and his wife is kind of jumping around, playing the field, getting new jobs. And the answer is sometimes a little bit more simple than we might think. We've tried all kinds of things, like giving them wall-to-wall pizzas and scatter cushions and ping pong tables and all of that kind of stuff. But actually, when it really comes down to it, once we've got the money side of it sorted, it's really, do we enjoy what we do and do we trust the people that we work for? Engineers like to do interesting things. They like to solve interesting problems. So really, we need to allow them to innovate. And more importantly, we allow them to innovate in a safe and secure place, right? A place where they can make mistakes, try again, and move on. And I'm sure you've heard this before, so I'm not going to labor it, but really, it is pretty simple stuff. So finally, you've kind of worked out the process, you've worked out the tools, you may even have worked out the people. So what does that amount to in reality? It means you have to work out your culture, whatever that is. I once heard a guy called Michael Coate, you may have heard of him, say that culture is the operating system of the people, which is a kind of neat way of saying that it's, you need to create an environment for the people in which to operate, right? You may you may think, you have to work this out for yourself, really, to be honest. What is your culture? You may think you have a environment which is good for innovation in a safe space and all of that, but how do you know? What do you do to check that out? In Discover, we're pretty big on this kind of stuff, I would say, but there's no point just saying it. You have to actually mean it. And in the case of this stuff, you have to actually ask people whether that works for them. In the DevOps world, we're very used to measuring ourselves with metrics against our delivery pipelines, but it also comes down to asking people what they think and being prepared to act on it if they say it sucks. And at the end of the day, it doesn't hurt to be nice to each other. So finally, I think it's always good to leave people on a quote. And this one is from a very, very famous DevOps evangelist who knew quite a bit about gradual transformation. It is, of course, Mr. Charles Darwin, and he said, "It's not the strongest or most intelligent that survives, but the one that's most responsive to change," which I think we can all identify with in this DevOps era. And with that, I shall say thank you very much for staying to the end of the credits. Software is a team sport, as we all know, but I just wanted to give a quick shout out to some of the stars of the Discover show who've helped us move our mainframe to the cloud. Thank you very much.